Okay. Uh, Hello everyone. Uh, Welcome to introduction lecture. Today our subject home energy management products and trends. Actually, it's a hot topics in electrical, electronics, and mechatronics engineering. Because home automation, home energy system automation, etc., is very uh, hot topics in our engineering study and the industry. So. Every week we need to talk about the hot topics in electrical engineering. Uh, in first slide, you can see our home energy management laboratory in Okan University. We have 6 kilowatt solar panel and the solar energy production system. Also, entrance of the building, we have a solar inverter system. Also, we have some house loads for application and simulation studies. So, okay, ongoing technology trends, including decreased sensor computation and the display costs, more pervasive integration of device level information processing capability and networking communication, and increased interest in electric demand response, and the rollout of smart utility meters have greatly increased the opportunities for home energy management and enhance their potential viability. To exploit those opportunities, a growing number of new home energy management products and the companies have emerged over the past decade, ranging from basic energy displays to home control system and smartphone application. The great diversity of home energy management product features and types points in indicative of the emerging state of the home energy management industry that currently has relatively low market penetration. For example, in United States, a company estimates that approximately 6 million United States households will have some type of home energy management system in 5 years ago. Today, nearly this population reach up to 10 or 15 million United States house. This equals actually about 10% of households. Some home energy management systems try to increase communication between utility and consumer. The directionality and sophistication of such communication, however, still varies among products. And many products that seek to provide real-time feedback on electricity consumption and send information to the consumer only. The growing trend, rather, is to develop two-way home energy management products that can connect to a home area network and to control different devices in the home. Such is the case with current home automation and demand response efforts. Here, actually, demand response and the peak energy consuming shaving is another important criteria. In that case, the end goal of home energy management and smart grid at the residential level is to manage energy consumption profiles to reduce peak electric demand and reduce consumers' electric bills. This may reflect the gradual progression to a smart grid, but may also be due to challenges with homeowner adoption and the effective use of feedback system home energy displays that were initially developed. For any home energy management system to achieve mass market penetration in the industry must overcome challenges to enable consumers to easily sell, install, manage, and secure home energy management solutions. As note above, home energy management is currently a smaller emerging market. Moreover, some of the most significant players on the market, Google, Cisco, Microsoft, have decided to exit the industry, citing a lack of growth and consumer interest, actually. Current research should be focusing on this general lack of market acceptance. Moreover, the success of home energy management products depends largely on how home occupants act upon the energy feedback itself and to what degree. Therefore, considering user preferences and providing relevant, actionable information should be point of focus. So perhaps the biggest barrier to greater deployment of home energy management is that consumers currently need to invest in additional tools, home energy displays, software, sensor, etc. Why? To obtain real-time feedback on their electricity consumption. This makes for a market filled with early adopters and technology enthusiasts. Consumer research suggests that the average user is not yet willing to learn the necessary information to install and navigate current products. A clear example of this in the current market actually is that of programmable thermostats, which are typically used successfully only by approximately 50% of home in Turkey occupants and don't yield clear energy savings relative to non-programmable thermostats. Uh, in Europe, the Fraunhofer Center for Sustainable Energy System leads to building America Home Energy Management Standing Technical Committee to help guide the center discussion of home energy management market opportunities and research needs crafted this taxonomy of current home energy management products, as well as a list of home energy management products and their functions and prices. Actually, here in this slide, in Europe and United States, in our respect to the vision, one side y-axis consumer energy savings, another aspect connectivity actually. Firstly, paper bills is important. Actually, here all topics are important for research and technology management, etc. Paper bills depend on consumption trends and neighbor comparisons. Another criteria, web portal, consumption trends, neighbor tracking, and social network. For example, in Turkey, in Anatolian Asia Electricity Company is called as a ISH, Enersa. We have just consumption trends, actually. You can download from the internet application and you can track your consumption trends. It's just an simple example. But the next years, we have consumption trends, neighbor comparison, neighbor tracking, social networking, also standalone home energy management, consumption estimation, device level tracking, automatic device control, also in-home display. Every home will have display for energy metering, smart energy metering system. Here, meter-based consumption, bill-to-date information, home automation control, etc. Also, demand response load control and auto pricing response. Actually, here 5G communication protocol is important. In next years of our life, probably we can use 5G protocol in our all home appliances. For example, actually in your home probably all LED or LCD television have communication protocol, but in your refrigerator, washing machine, etc., don't have any communication protocol. So in this area, we have big players: Schneider, General Electric, Honeywell, Logitech, Whirlpool, Siemens, etc. Also, we have smart small companies, Ecobee, Lyrico, Rainforest, O-Power. Also, we have IT giants, Apple, Google, Cisco. These are the big players. However, we have communication barriers here. So all companies needs a communication company. For example, Cisco is the biggest communication automation company actually. Also, Google uh, helps to Cisco for smarting of Internet of Things, and Cisco helped Google about some communication automation side of this technology. So we have decided the following classification system for all types of home energy management products available in the residential market. The three basic categories are control devices, user interfaces, and enabling technology. These categories are not mutually exclusive, but are meant to capture the key aspect of typical home energy management devices. Individual products may fit into multiple categories. For example, the uh, TED package reads usage data using current transformers, provides data via a display as well as through a web portal or standalone software, and uses its own gateway device that communicates using Zigbee. Here, it's important that which communication protocols are suitable for home energy management sensor networking. Maybe after course you can download paper about the home energy automation communication protocols. Okay, the home energy management market today consists of a range of hardware and software solutions that sometimes work with smart meters that are only provided through utilities. So control devices allow the consumer or utility to actively control energy use with varying degrees of automation, human in the loop. In this table, we summarize the different levels of control and representative example, actually. User interfaces, also we call as a UI, also human machine interface, HMI, provide energy feedback to consumers. Raw UIs also refer to as direct feedback, provide more basic information with limited processing to inhabitants such real-time and/or historic data on energy consumption in kilowatt hour, dollar hour, dollar over hour, watts over hour, etc. In contrast, user interfaces with processed data, also referred to as indirect feedback, have the potential to give users a better sense of personal significance of raw usage data and how to act upon that information. Examples of processed information include energy consumption by end use, circuit, or device, historical comparisons, trends, personalized, targeted recommendation, and goal setting. Another important attribute of user interface is the information display medium, home energy display, firstly, standalone home display, often portable. Another one, web dashboard or portal. Another one, smartphone application, you know. Current products typically pull information from an generated process data, but may also provide raw data, you know, and other, etc., television, etc. Enabled technologies are the underlying framework that supports obtaining, processing, and communicating information about energy usage. And this table, enabling technologies, you can see enabling technologies are not home energy management system per se, but are integral of their function. First, enabling technology sensing, communication, and communication protocol. In our home energy management actuator, smart meters, temperature sensors, occupancy sensors, time of day, communication, gateway, range extender, home area network, protocols, actually Zigbee, LoRa, UPB, X10, 5G, Wi-Fi, Bluetooth, etc. Sensing data involves accurate information, often integrated into home energy management systems about dynamic variables related to home energy management. Smart meters gather temporal data on electricity usage. Temperature sensors and occupancy sensors characterize the home environment. Information about electrical usage, temperature, and occupancy combined with external information such as time of day and the weather data can be used to customize energy management for an individual home. Some companies, which Landis and Jira and Elster, examples of this area companies that specialize in smart meters. Many companies, include DG and Ecobee, offer temperature and occupancy sensors. Also, communication protocols and standards facilitate communication and may support the home network. Gateways are devices that connect the HN to the internet. Range extenders amplify signals to expand the area covered by a single network. Many companies manufacture their own gateways and range extender to be compatible with their home energy management system. For example, Xiaomi company. Communication protocol standards and the facility communication. Actually, typical example of home energy management system you can see here. This figure shows several home energy management control products available on the market today that don't require a smart meter categorized by functionality. Home energy management products can allow the user to monitor energy usage, remotely manage energy usage, such as adjusting the thermostat while away from home, and automate energy savings, either with sensors or via user-programmed schedules. For instance, smart plugs such as Kill A Watt by P3 International analyze and display energy usage at outlet level. Wall home systems usually use some combination of current transformers to measure electricity usage at the socket level, along with a wireless network to communicate the data to a home energy display, such as energy detective. Further, some monitoring systems, like the e-monitor, also provide software or web application to view aggregate data on a personal computer or online. Firstly, we can talk about the centralized control. Because of its potential to manage electricity consumption and demand for multiple end users, home automation is an integral home energy management subsector. Although several companies sell home automation products, many of these products are still being developed and not always readily available for purchase. In our application in the market, you can see smart lighting system, advanced lighting control systems allow home owners to dim lights, to lower energy use and turn lights off via occupancy sensor, timer, schedule, or remote control. Lighting control can be at both the centralized and device levels. Some type of lighting system, dimmers, timers, occupancy sensor, wireless dimmers, wireless switch for controlling remotely. Home control system can incorporate lighting control, motion sensor, dimmers, remote control scheduling, thermostat load control modules, and the appliance modules. Also another one, remote control dimmers, appliance control thermostats. Actually, next step, thermostat, device level control, with the space heating and cooling comprising more than half of residential energy consumption. Smart thermostat are an important element of a home energy management system. A smart thermostat is a thermostat that can communicate with other devices. This differs from a programmable thermostat that can only be programmed to automatically reach different temperatures at different times. Actually, in this slide, you can show uh, General Electric net zero building system in 5 years ago. Here they have Home Energy Manager. Home Energy Manager, you know, the central system is the adjust zero energy control, zero full energy production, and it manage consuming of electricity and heating energy, so gases energy, etc. Here in this home, solar photovoltaic and the small wind generator. It's in hybrid system. Solar photovoltaic product 3 kilowatt to 4 kilowatt energy. Small one wind generator, actually it generates 1 or 2 kilowatt in your roof of building, top of building. Also, in entrance of building, they have smart meter. Smart meter actually communicate with the energy company. Also, geothermal heat pumps. Actually, in your apartment and the old building, we have no geothermal heat pumps, but in United States, that very rich people have the system. Also, heat pump, water heater, energy storage system. Actually, for because energy building, energy storage system actually is important because new regulation in law, it is okay for selling your own energy to the government. Also, if you have more and more energy, you can sell your electricity to the producer electricity company. Also, another one, energy efficient lighting, and also demand response appliances. What's it? You can measure your white goods appliances in your home. Next example, Huawei system. In Huawei system, it is a new system. Here we have a smart PV optimizer, smart PV management system, Izalo Cloud, smart energy center with solar inverter, storage system with the battery, also smart load, smart home hub, and the smart power sensor and AC distribution box. Here very advanced system you can see in left figure. In Okan University, we developed a system. You can see first figure. Is our laboratory. Here we have solar powered energy management system with the some house loads. Our main aim here like Huawei system, but it is We have here a renewable energy in top of building, solar powered. Also, we design a hardware for home energy management algorithm running. It monitoring statistics, it calculating, also it estimates some uh, energy demand. Also, he calculate the usage patterns. It calculate usage patterns. Also, we have smart energy storage batteries. Also, most important specs of our system, our developed system, big data management. It generates energy production, consumption map, device management, tariff management, energy optimization, energy efficiency, grid, green counter, grid operator feedback, using cloud monitoring of all appliances data and the meteorology data and weather forecasting respect to the tariff electricity price data. These systems have four inputs. These inputs are firstly electricity price, government electricity price. Next one, load estimation, user consuming estimation. Next input, solar capability estimation. Another one, battery state of charge. Our outputs in the system, comfort and cost. We can regulate the cost over comfort in this system. Our main hardware calculates the electric price, estimated energy demand, estimated solar power potential, and battery state of energy charge. And its outputs calculate the cost and comfort. If cost is high, our system regulates to solar battery energy to usage of human. If comfort is high, our system use the grid energy. Typical home energy management application, actually. Also, in thermostat system, after that, this example, smart plug, next things in home energy management system. Plug level solutions offer monitoring, control, and even automation at the level of individual sockets. In our home system, we have smart plugs. Our smart plugs generally has one or more, generally more, always on plugs for television control box, and the 5 or so plugs that automatically turn off the other entertainment devices when not in use. A more expensive smart power strip in a market, such as the Belkin brand, will also have a control appliances that automatically turns off all of the other plugged-in device when the control appliance is turned off. Next example system, onboard control system. GE, I said as an example, General Electric company system. Very old system actually, it's 8 years ago. It's available in the market. Their product, Network Communication Appliance Suite. dishwasher, double oven range, front load washer, and dryer refrigerator, programmable thermostat, energy display, smartphone application, and web portal. It automatically delays appliance use until off-peak hours, requires Zigbee smart meter. In Google system, it's called as a Nest company, Android at Home protocol for controlling home appliances and thermostats with Android devices, Android controllable light bulb in development with Lighting Science Group in Google. Another system, LG, its brand Think smart appliances display energy consumption and can be scheduled to run at off-peak hours. Washing machine, dryer, oven, refrigerator. They support Wi-Fi and Zigbee to communicate with smart meter and smartphone. Actually, 5 years ago, Zigbee and Z-Wave protocols are leader communication protocol in smart energy management systems. Today, generally, we have LTE, Wi-Fi, and LoRa system are leader in industry. Also, another example, Whirlpool system. Whirlpool system actually energy efficient refrigerator with built-in sensors to automatically adjust cooling. Oven with energy save mode, washer and dryers with eco monitors that provide feedback on the eco-friendliness friendliness of the user's choice of cycles. Okay. Another component of home energy management system, user interface, Many user machine interface, human machine interface provide real-time electricity monitoring of the entire home in current kilowatt hour over hour or daily kilowatt hour. Currently available models tend to be similar in the general types of information and visualization they present to the user and don't provide household controls. Installation for these models typically involves current clamps on a home circuit panel. Actually, doesn't interact with a smart meter. In this area, important companies to save energy: Alert Me, Black& Decker, Blue Line Innovation, Brultech, etc. Also EcoY, Kyoto, FRG, Energy Incorporate, what Vision, also Savometer, etc. Also, next topics, process data in home energy management system. We have some application for process data. One of them, appliance breakdown. Next one, suggestion and tips. Next one, email alerts. Another one, social comparison. Another one, social media. In today, general approach in process data, you can download the program from internet or you can download the application to the phone. You can watch and control your own home data. You can track your statistical data, and also you can measure your own energy consumption and the energy price. Another type, web-based process data solution. In some cases, displays and supplemental web software packages provide additional information, including household baseline energy use information, energy use trends, projections, alarms, social comparisons, and goal tracking. Some companies develop these capabilities themselves. Nearly, for example, Fibaro company, actually most important company in home energy automation system. Maybe after lecture you can search in internet. Other third-party freeware options are able to connect to data tracking system like the power cost monitoring, which has an open platform in internet, power cost monitor. This is generally done through a host URL or port forwarding methods. Dashboards allow to users to view their energy use from anywhere that they have web access, whether on a computer, tablet, or smartphone. Until recently, Google PowerMeter and Microsoft HOM were the two major competitors in this area 5 or 6 years ago. But today, lots of company are competitive. Currently, early adopters must find a replacement to continue to monitor their home energy use on the web. Lots of startup companies and spin-off companies are product their own system. So a number of new freeware options. I upload the last two course slides. You can check. And today I will upload home energy management system and protocols and trends slides. You can check all our system, please. Okay. Okay. Nerede kalmıştık? Evet. Huh. We can talk about the power cost monitoring system. I think I said you what I said again. You can search in internet, for example, Fibaro application. In all white good appliance connect with a smart plugs. All data comes to the main modem systems using Z-Wave protocols, and you can track all statistical data, all on-off controlling data, all remote controlling data. You can when is the midterm? When is the midterm? Your midterm date is available on Okan University Engineering Faculty website. Okan University Engineering Faculty announcement website. Okay, do you have any question? Okay, we can say lastly, talk about the phone application for home energy management system. Lastly, uh, generally, while most web dashboards can also be accessed through the web browser on a user's smartphone, applications have also been developed specifically for mobile phone use. And if the current market is any indication, mobile solution for both monitoring and controlling could be the next big branch in home energy management system. In fact, recent survey work has shown that early adapters prefer and are more likely to adopt smartphone application over web dashboard on home energy. No. Any Turkish houses have no home energy management system. We have no. It's the Dear Abdulrahman, in Turkish houses, generally expensive houses have home energy management system, but they are very simple system. It's like a home energy management system. Smart meters, maximum smart meters, uh, smart fuses system. Also, probably after 10 or 20 years later, all Turkish homes probably have home energy management system. It's not that today in the United States, generally expensive houses have home energy management system because we need to have all white goods for application your refrigerator, your television, your heating system need to have communication protocol. But in my home, my refrigerator has no any protocol. Subject, the exam subject is in your recordings actually. First 8 week slides in your all learn system. Please listen again your recordings. It's very simple questions you have. We have no any idea about the multiple choice question, Abdul Kadir. We have no any idea now. Maybe a multiple choice, maybe classical uh, calculation exam, but it will be easy. Don't worry about your exam for this course. Please listen to recordings of lecture and please try and follow your slides. Probably a DC motor question I will ask. Any standard question I will ask. And a simple question about the home energy management system overview I will ask. Also, Professor Nejat will ask 2 or 3 questions for you first 4 week. Probably his subject, I don't know his subject. Okay, today is enough. Some students have exam probably. 2 weeks later, see you. Take care, friends. Do you have a question, any? Okay. Yok yok, zor değil, rahat olun. Sınav kolay arkadaşlar. Bir problem olmaz. Şeyleri izleyin. Okay. Thank you.